All right, we are starting a new unit focusing on polygons, and eventually we're going to then be focusing primarily on quadrilaterals. But first, let's talk about what polygons are. So we have four properties that define a polygon. The first is that it's a plane figure that consists entirely of segments. The consecutive sides intersect only at endpoints, and non-consecutive sides do not intersect. Each vertex of a polygon must belong to exactly two sides, and consecutive sides must be non-collinear. So we have some shapes below, and we're going to classify them as polygons or not polygons. So this first one here is not a polygon because it does not contain only segments. This curved side right here is not a segment. Remember, a segment is a straight line. This triangle, of course, is a polygon. This is a polygon. This is a polygon. This is a polygon. This is not a polygon because we have consecutive sides that are collinear, so that is not a polygon. This one is not a polygon because these two points, each vertex can only belong to two sides, and these two vertices belong to three sides. So that's not a polygon. This is a polygon, and this is not a polygon. So our next question is, why is a circle not a polygon? And that would be because a circle does not have segments. Remember, a polygon must consist of all segments. Okay. Now we're going to talk about the difference between a convex and a concave polygon. A convex polygon is one where each interior angle has a measure less than 180 degrees. And this one here would not be convex because this angle E here is greater than 180 degrees. So if a polygon is not convex, then it is concave. So this is a concave polygon. It is not convex. Moving on to our next page. All of these figures below, it's a little hard to see with this light. Let me turn the lamp off. Nope, that made it worse. All of these figures below are polygons. We have a parallelogram, rectangle, rhombus, kite, square, trapezoid, and an isosceles trapezoid. And we're going to get into more details with each of those different quadrilaterals throughout this unit. But first, using the definition of concave and convex that we just learned, let's see if we think that these quadrilaterals appear to be convex or concave. Now remember, a convex polygon, each interior angle is less than 180 degrees. And if it's not convex, then it is concave. So looking at all of these polygons, it does not appear that any of them have an interior angle greater than 180 degrees. So they are all convex. All right. Now we are going to start talking about one of these special quadrilaterals today called a parallelogram. And we have, 5 properties that define a parallelogram. The first one is that the opposite sides are parallel. So PL would be parallel to AR, and AP would be parallel to LR. The opposite angles are congruent. So angle A is congruent to angle L, and angle P is congruent to angle R. Oh, we have this one on here twice. Sorry, opposite angles are congruent, opposite sides are also congruent. So PL is congruent to AR, and AP is congruent to LR. The diagonals bisect each other, so these two segments are congruent, and these two segments are congruent. And lastly, any pair of consecutive angles are supplementary. So A is supplementary to R, A is supplementary to P is supplementary to L, and L is supplementary to R. Any two consecutive angles are supplementary. So let's look at a couple practice problems here now, starting with number 1. Are the quadrilaterals below parallelograms? So on this first one, I'm given some information, and in order to make this determination, it's going to come down to angles. And so I have two properties that have to do with angles. The first one being that opposite angles are congruent, and any pair of consecutive angles are supplementary. So if I can fill in the missing angles that I don't know, I can determine whether or not this is a parallelogram. So my first thing I'm going to do here is I'm going to assume that this is a straight line, and a straight line is equal to 180 degrees. So if this angle is 70, this interior angle would be the difference of 180 and 70, which is 130. So that's 130. And same thing with this. I assume this is a straight line. If the exterior angle is 70, then the interior angle is 130. So I have three angles, but I need to know about angle G before I can, with certainty, determine if this is a parallelogram. And the sum of the interior angles of a quadrilateral is always 360 degrees. So if I subtract 130, 70, and 130 from 360 degrees, that leaves me with 70. So angle G is 70. So my opposite angles are congruent, and any two consecutive angles are supplementary. So I can say with certainty that, and I do apologize, Ms. Treadway made a mathematical error here with my mental math, and I'm sorry for that. If this is a straight angle and the exterior angle is 70, the interior angle would be 110, as would angle H. So those are both 110, and if this is 70, the remaining angle is still 70. 360 minus 110 minus 110 minus 70 is still 70. So my opposite angles are congruent, and any two consecutive angles are supplementary. So yes, this first one is a parallelogram. Let's look at the second figure here. I'm given information again about the angles, so it's going to come down to those two properties about opposite angles being congruent and our consecutive angles being supplementary. So I'm given information about opposite angles, and angle E is 85 and angle G is 86. So this is not a parallelogram because angle E is not congruent to angle G. Moving on to our last page here. So on number 2, we're told that ABCD is a parallelogram, and we want to find the values of X, Y, and Z. So remember our properties of parallelograms. These are all angles that I'm looking for. So my opposite angles are congruent, which means that Y is 65. And my consecutive angles are supplementary. So if 180 minus 65 is 115, that means that Z is 115. And then again, angle X here is this X value is an exterior angle, so I need to find the interior angle in order to find X. The sum of the interior angles are 360, so you could find it that way, or we know that opposite angles are congruent. So this is 115, which makes X also 65. So X is 65, Y is 65, and Z is 115. Okay. Now we have one more problem here. We're told PQRS is a parallelogram, and we want to find the values of A, B, X, and Y. And it looks like I'm missing a couple values here, so hold on one moment. All right, so this side, PS is 8 and PQ is 15. That did not come through on the notes, I apologize. So remember, one of our properties of parallelograms is that the opposite sides are congruent. This value A is opposite PS, so that means A is equal to 8. And this value B is on the side opposite PQ, so that means that B is 15. Now we can start to find our X, Y, and Z. Remember, opposite angles are congruent, so that means this is also 80. So X is equal to 80. Now y is where it's going to get a little tricky. So remember, consecutive angles are supplementary. So this whole angle plus 80 degrees should be 180 degrees. So 30 plus y plus 80 equals 180 degrees. 30 plus 80 is 110. So to solve for y, I subtract, and I get that y is 70. And that will conclude our notes for today.